Fine. So today we are going to see, we have just this modeling part. Like we started with the modeling, right? So we said like we will today we will see more on the modeling. And yeah, that's what we are going to see. The data warehousing basic concept, fine. The basics of data warehousing and what are the different modeling technique we have. So, do you have any prior knowledge on modeling concept, like how these modelings are done in data warehousing? What are the different types of modeling we do use?
I have some some experience like building some dashboards, but like it's everything like from the YouTube videos that I have learned, and it's more of the practical knowledge. So theoretically, I haven't learned. Uh,
Okay.
I just have a basic knowledge of how to build the dashboard, how to import, and how to create. Just interacting with the UI and nothing more than that.
Oh, then you have lot of yeah, you have enough knowledge on them. This.
A
Okay.
little bit of it, yes, yes.
Yes, then okay, fine. We'll see the data modeling concept, and we are going to not cover everything, right? So here we have only one session for data warehousing, and we are going to see what are the different, terminologies. Not all the terminologies, but the used terminologies we'll be using here. So that's what we are going to see. What are the different things we have in data warehousing, right? And the yeah, just some definition. That's all. Okay. And we are going to see how
I just
data
placed them.
flows. Yeah,
I just put it right.
yeah. Okay. So we are going to see like how data flows from the sources to the reporting environment, right? What are the different things involved? Then we are going to check like how what are the data modeling technique we are going to use, or in the data warehousing it's being used, and similar thing we'll be using also in Power BI, right? Similar technique to create the data model. Right? So, Leah, we did see before in this. So, we had already seen that to get data from two different sources, okay, two different tables, right? We have to make, we have to join these tables. So what are the different effective way? We have many tables, right? Many for we have many tables, right, for an entity. Then what we are going to, how we are going to join those and get the data effectively, integrate the data effectively, right? So for that, we are just going to see the modeling, right, in data warehousing. And so, yeah, as far as this data warehouse goes, right, what do we have in the data warehouse? What is this data warehouse, right? So data warehouse is an information system, right? It will store the historical and cumulative data. What does that mean? That it is in data warehouse, we are making, we are doing daily business, right? And that everyday data is getting stored somewhere, right? So in this data warehouse, all these data are being parked to the data warehouse, right? And it will store the data for few years, right? On relevant years, not those data which are not relevant at all, right? So we'll have all the data parked at this place only for which is relevant to the business, right? Which can help our business improve, right? And why we are parking that data, why we are having that data into the system, data warehousing system, right? Why we park that data? Because we want to analyze that data, or create report or integrate, okay, the transactions, data from different sources. So analyze and creating report and integrating the data integrating the transactions from different sources. What may be the different sources of data we have? We we have businesses in different geographical regions, right? Maybe somewhere we have a small store, somewhere we have the big marts and all, right? We have uh, big stores. So different at different places we have different sources of we have different techniques to collect the data, right? Somewhere we are using the Excel file only to collect the data, or somewhere we are using the databases, right? Using proper application, right? So we have different sources of data. So when we have different sources of data, and we want to analyze the data from all the sources, we have to integrate it. So that's where we have to bring all the data together at some place. Otherwise, what we need, if we want to analyze the data from different sources, we have to connect to all the individual sources and get the data, right? Instead of that, we are pushing all the data, parking all the data at one place, placing all the data at holding one all the data at one place. That is called data warehouse, right? And data warehouse is just the analysis and reporting process of an organization. Yeah. Why everything is together at one place, right? And it is also a single version of truth. So you will find all the true data at one place. So this data will be correct. So before placing all the data into a data warehouse, there are so many rules, regulations are applied, right? Rules are applied to correct the data if data is not correct, if data is not clean, if something is missing. So everything is corrected and put it into the data warehouse, right? And this single version of truth of data, we can use it for decision making, for forecasting, right? For other activities, right? Uh, and improve our business. So here now in this pictorial form, you can see that these are the data sources from where the source data will come. So this you may take it as some store, right? These may be some stores, and these data it may be pushed to the data warehouse, okay, every day, or it may be pushed every week, right? Weekly, daily, or every night. So generally, what happens? The data is being pushed to the data warehouse during the non business hours, okay, during the non business hours, once the business is closing, right? Then after the data is transferred to the data warehouse from the transactional systems, right? So that's what happens. Data integration happening from different sources, all the different sources, and it is moved to the data warehouses. Right. And here also we have different, schemas. Maybe somewhere we have staging area where the data is first moved from the source system to the staging area, and any rules we want to apply. So we apply in that area, then we again move to the final data house, okay, data marts, right? From data mart, the data is being used by the analytics tool. It may be Cognos, it may be Power BI, it may be ClickView, or it may be any Tableau or any tool, right? So here, and you can see that for different business area, you can now do your analysis, right? HR, marketing, finance, and you have also cubes you can do here. So now the question comes, like, why do we study this thing? Because this is a complex system. You can see this is a very complex system. Lot of tools are involved in data warehousing, right? Here we have ETL tool, we have reporting tool, we have databases, right? We have source systems, so files, flat files, databases, and many other websites. So many things are there, right, in the source systems. And yeah, so you have to understand each and every thing once, if you are managing the project, or if you are working on the analytics tool, right, as a data analyst, right, you don't have to bother about these ETLs and all these things. Only thing is you need to understand the architecture, like how the data flows into the final system, so that if there is any issues in the data, you can backtrack. Fine. So you need to know these things. Fine. There are a lot of teams involved in this also. A lot of teams involved in the ETL processes, and from pushing the data. So you have many teams maybe from the source systems. Okay. Then you have data warehousing, maybe one team or two team like that. And again, you have separate teams for which is consuming the same data for different business, right? Maybe for finance, marketing, or in insurance also we have PNC, we have RIS, right? So many things are there. So you will be having different teams who will be consuming this data warehousing data, right? Right. We now let's understand a few terminologies, right? Here, so we also have. So what is the again? We are already using the databases, right? We know the database Oracle. We use Oracle. We use some other database, SQL Server, right? Many other databases we are using. So and we have also data warehouse. So what are the differences between what are the difference between database and data warehouse? Fine. Why do we have these two? So you may, you may already know that in databases, what are the activities you are performing? Mostly, you are performing the, transactional activities. So OLTP system database is being used by OLTP system, right? This is OLTP system. So database uses online transactional processing, where you are you have a store, you some customers are buying something, so you are entering the order details and all these things, right? So at that is transactional system. And when you are going to analyze the same data, you are parking that data into some other tool, right? Some other places. That is OLAP system, right? Data warehouse uses OLAP, online analytical processing, right? That is in online analytic processing, where you don't use the that is not a transactional data, that is being parked, that is being transferred from the sources to the OLAP system, right? You have again different tools and different capabilities of this OLAP and all, right? Where you can use cube to collect data, you can use various types of data, fine. And it can handle a lot of complexities, right? It's a heavy software, right? A lot of options, a lot of things will be available in these systems, fine. And now you come to this, database is a collection of related data that represents some elements of real world, right? Is a collection of related data that represents some elements of real world, whereas data warehouse is an information system that stores historical and cumulative data from single or multiple sources. Here you have in the database, suppose you are working on a airline booking system, okay, ticket booking, right? So you have applications, you have applications for that, uh, where you are booking a ticket, right? So that will represent the database that will be used, that will be using the database. Yeah. If you want to analyze the data, right, you have everyday transaction from the database where you are booking the tickets. So you have gathered the tickets for last 2 5 years, okay. And You want to analyze which season the more tickets getting sold and all, right? So you are then transferring all this data to another system, which is data warehouse, right? And this is information system stores historical and cumulative data in that case. So we'll see some of the examples, like where we are using, how we are using the data warehouse and how we are using the databases. Fine. There are some properties here. You can see that database is designed to record data, right? It is designed to record the data. It is designed such a way. So you may be confused, like, okay, we also use the database in data warehouse, right? This is a part of storage. In data warehouse, it's a part of storage, but you have again many more things in data warehousing, right? Uh, Here in database, it's a part of application. Here, whatever record, whatever business you are doing, and you want to record, the daily transaction. For that purpose, you are using the database. And here, why you are using the data warehouse? To analyze the data. Okay, so from different application, here you are getting the data from one application. So here in this case, in case of data warehouse, we are getting the data from multiple applications and integrating at one place, right? Here also you are using the same, maybe in this case you are using the database as Oracle. So in data warehouse also you can use the database as Oracle, right? But you have also different versions of Oracle and all, right? For using lightweight and heavy software. So many things are there, right? So data, these are storage. You can use the same storage, similar storage, but concept is little different. Here it is data is stored to analyze the data. Here just you are keeping the data, recording the data. So while you are recording the data, in this case, you don't need to, integrate all the data. You don't need to show everything. You are just, creating a tables in normalized form. So you have to understand those concepts. What is normalization? What is denormalization? Right. So here, while you are keeping the information, you are keeping all the data in the normalized form, recording the data in the normalized form. In that case, there is less overhead while you are entering the data. Okay, you don't have to enter. You may have customer information where you are just putting the customer data, customer ID, customer name, something like that, right? You don't have everything on the our customer address ID, something like that, and it is very normalized. Okay, but in case of data warehousing, the data will be, in such cases, right, where you are going to, use, you are going to use a concept such that it is in the denormalized form, so that getting data, integrating data is easier. But if it is in normalized form, data will not be, the complexity will be more. You have to create more joins and all. So you have to understand these concepts. I am not going to, describe that, but you have to understand this. That's what I said. Like, okay, tables, uh, database tables and joins are complicated in case of OLTP system because they are in normalized form, right? Whereas data warehouse tables and joins are easy because they are denormalized. Fine. Uh, so ER modeling techniques are used for entity relationship modeling here. ER modeling means entity relationship modeling techniques are used for designing database, whereas data modeling techniques are used for here it's a data modeling techniques, and we are going to understand the data modeling techniques, right? Because we want to integrate, we want to get the data from different from the data warehouse and use it in our reporting system, right? For reporting purpose. So we are going to understand the data modeling technique. What are the data modeling technique we have? And but in the database, while data base is designed for online transactions, right? OLTP system, then their ER modeling techniques are used. Fine. Okay. Now, so we'll be understanding this data modeling technique. Fine. Okay. So, yeah, uh, here database is application oriented, right? Database is application oriented, and data warehouse is subject oriented. So what does that mean? Application oriented, you have one application, you have ticket booking application, right? So whatever data is required for ticket booking application, all the data will be, recorded in the system databases. All of those data, whichever is connected or related to this application, all of those data will be recorded in the database. Fine. But in the data warehouse, it is subject oriented data. Okay. Subject oriented data in the sense, for a particular subject only, the data will be kept at one place, right? It may be HR data, right? In a company, we have so many things, right? So only HR data we want to have. So for that subject, we have the data, right? We have the data for insurance. We have the data for finance, right? We have the data for marketing. For each subject, we have the data, stored. Information is stored at one place, right? So that's what, in data warehouse, the data is subject oriented, right? And in database, it is application oriented. Okay. And why to use data warehouse? Fine. We had already seen, like, it reduces a lot of complexity, because we are going to use the data modeling technique, right? Where data is in the denormalized form. So we can see, like, helps business users to access critical data from all sources, all in one place. So all the data is in one place now in data warehouse, right? And business users need not connect to all the different sources to get the data, right? So they can access all the data from one place only. That is one of the benefit. And here we have the provides consistent information on various cross-functional activities. So cross-functional activities, information is getting into one place from all the different places, right? And so here we will be able to use that consistent data. Consistent data in the sense, it should be same from the whatever is in the different applications. So same data should be also available in the warehouse. Right? Helps integrating many sources of data to reduce stress to the production system, right? So you already integrated data and then used in the production system, so that will uh, you know reduce the stress on the system, right? Otherwise, if you just in the production system, if you wanted to connect to all the different sources, so you have to create a lot of joins. So if you are creating a lot of joins, so network bandwidth will be used, and so many network overhead will be, there will be so many things, right, involved. So in that case, you may not, also the throughput and all those things will be, an issue here, right? So data, you have to connect to many different sources, many tables, and that will be a lot of stress. Fine. But here data is integrated in one place. That means in, you can say, in one table also, in the fact table, and you are just connecting to those fact tables, right? Directly you are getting the data from one subject area. Okay, so it will be easy, and we'll be just seeing the different modeling techniques, right? Less turnaround time, reduce the turnaround time for analysis and reporting. You don't have to do much. Here, access critical data from different sources. We have already seen, right? It saves users time to retrieve data, retrieving data, information from multiple sources. You can also access data from the cloud easily, right? So these are various, you know, benefits or use of that. So you can check the data warehousing concept. What are the different data warehousing concept things are there? You can check more on these things, right? And we have a lot of documents. You have a lot of uh, in websites, right? Various websites. So many good documents are there. You can check all those, right? Fine. There is something like, okay, separate analytics processing from transactional databases. So analytics processing, uh, so transactional databases are, where transactions are happening every day. And for our purpose, for the analysis purpose, we have a different system, right? We don't use the transactional systems. So it is separating the data warehousing is separating the database systems and keeping this process separate so that the business users, whoever is analyzing the data, whoever doing the analysis on the data for business loss or improvement or new opportunities, right? They don't have to work on the transactional databases, which is being used for businesses daily, right? So these are separate systems, okay, and that's how it will improve the performance of both the systems. So you are not burdening the systems, different systems, right? Yeah, fine. We have the stakeholders and users may overestimating the quality of data in the source systems, right? Data warehouse provides more accurate reports. So while we have the data in at one place, so we also put rules in place so that the data quality and everything is corrected, right? Maybe whatever data we have in the transactional system, right, in the databases, that may not have a proper, that may need a little more processing to improve the data quality, right? Maybe missing data, maybe some you know uh, formatting. So many things are there which are being handled in the data warehouse. So in the data warehouse provides more accurate reports, right? Now characteristics of data warehouse. So you are understanding this, right? I think you are already aware of these systems. Maybe you are working on the data already. So if you have not if you have not come across these systems, right, you just go through some documents, you just check these documents, from internet. So you will understand, and you should have a proper knowledge on this because while you are working in an enterprise, right, big company, so all these systems are in place. Okay, they have all these data housings, so many this system will be in place, and you have to understand while you are fixing some data issues. Okay, uh, if you are working on the reporting side, you should have only theoretical knowledge. You don't need to have all the knowledge on these tools and all. So you should know how the data flows into the system, target system, and what is happening. So you should also know like what are the different sources. So these few things you should know while you are working on the target system and you are creating the report, right? Uh, so yeah, we have the characteristics of data warehouse. These are the, we have already described these things. So characteristics of data warehouse is subject oriented. You will have data for one subject, particular subject, right? You have integrated data from different sources, right? You have time variant data. That means data will be there for few years, last few years, maybe 4 or 5 years, right? So it should be relevant data, not for just for keeping purpose, right? It should be relevant to the subject and to the business, right? Suppose we are having 10 years back data, which is not relevant to the current day business, right? Then that data is not going to, not going to impact the business decisions, right? So that is not required in the data warehouse itself. That should be taken away or purged, and that's those mechanisms also are in place, right? So some people, some businesses keep their data like for last 3 years data, some businesses keep 5 years data. So based on the relevancy, right, whatever relevancy to their business is there, so they just keep the data like that. Fine. You have non-volatile data. That means data is not getting the data is not you know changed or moved or deleted easily, right? Those are non-volatile data. So very in some cases only the data is getting changed, but not all, not frequently, right? So data is not non-volatile, and you can see like here some definitions are there, like subject oriented, it offers information related to it, to theme instead of companies ongoing operations, instead of operations or applications, you can say. So it is giving the data, subject oriented data is related to the theme, okay? And in this case themes maybe, here you can see these themes can be sales, for all the sales we are having a data warehouse, for distributions, for marketing, for product, right? Suppliers, all these things, we have some themes, right? So for all of these you have a separate, you create a data warehousing, right? You create the tables or measures facts, right? And similarly integrated data from different sources of data, we are just getting flat files, relational databases, websites. So many from so many sources we get the data. Time brand, we get the data from different time, right? Non-volatile, previous data is not erased, right? The previous data is not erased, and also new data is added in this case, right? And frequent changes are not happening. Okay, very less changes will happen in this data set, right? So, do you have any questions? Any question you may have? Okay, fine. So I think I see this is a very big. This is not just one day, topic, right? We are just seeing the few concepts, right? And just to give a little, you can say the hint for this concept, data warehousing concept. So there are a lot of things, involved, and you should check these things regularly. So this is not just one day work. Okay, you keep on, understanding each and one concept, maybe every week one concept, or whenever you are coming, come acrossing any any terminologies, you can just check, and that's how you will just understand. Or if you are going for interview, then you need to have these theoretical knowledge. At least you need to have this data warehousing theoretical knowledge uh, for uh, for uh, for an interview. Okay, so that will help you. And this is required while you are appearing for an interview. Fine. We have what are the disadvantages of data warehousing? So it's a complex system, a lot of cost involved, right? So many tools involved, so many resources will be involved. Yeah. Many things. So it involves it is high. It associates high cost, right? So yeah, we have these sometimes problems associated to the data warehousing is not detected, fine, because again these are a lot of tools, lot of things are involved, so you don't know where this issue is coming from, right? And you may have overlooked or not seeing it because data is there for last few years, and you don't know what whether the data is correct, not correct. So it goes undetected. Some of the data goes undetected for years even, right? And you are doing your reporting with that data itself, which may impact your reporting, right? If it is just somewhat near to your real data, so you may ignore it, right? You may think like, okay, this is correct, this but due to the incorrect data, it's impacting your reporting also. Fine. So that those this is the complexity because of the big data system here. Warehouse has higher maintenance systems, right? Extracting, loading, and cleaning data could be time consuming, and it takes time. Okay, it takes some time. Like, okay, I have worked on some project which takes even 3 days to load the data from the you know which loads the data from the source system to the target system. Okay, we used to do the ETL processing during the weekends. Okay, starting from Friday end of business time, then till Monday starting of business time, till that. And sometime what happens even Monday after even after starting the business, we still process the data. Right, it takes a lot of time, but nowadays a lot of tools have come which are doing faster processing and all, right? So that's why everything is changing every day, right? Because of this processing, and lot of data is getting generated every day now. Earlier it was not like that also, right? So a lot of data is getting generated, so you have to process all of this data. So for these things you need sophisticated tools, right? And that's why also sophisticated tools are coming every day in the market, right? You have data streaming things, you have big data systems, you have so many tools and technologies are coming every day, each and every day, right? So yeah, that's what. So you have to keep up with all of these technologies also when you are working on these systems. When we are working on this, uh, working as an analyst or working into the data warehousing systems. So you have to keep up with all of these new technologies every day coming in. Fine. Yeah. So apart from this big data system, apart from this data warehousing concept, you have to also understand the big data systems, whatever, what are the tools involved, how those are working. Even if you don't know, you don't need to understand everything, all the codings, everything, but at least you should understand which tool is doing what, right? So that I believe you all are experienced people, right? And you will be handling some project. In that case, you need to at least understand what tools are doing, which tool is doing what, and that's how you will be able to take some decisions on basis of the work, right? So yeah, and this data processing and everything in this data warehousing, we use the some tools like, okay, Informatica, we use data stage, various tools are there for ETL processing and all. And if you have already seen those tools, you may know that these are complicated. These tools needs skills. These tools, involve lot of cost. Fine. So data warehouse may look simple, you can see, but actually it is too complicated for the average users. Fine. You need to provide training to end users who end up not using the data mining and warehouse. Fine. Fine. So, despite best efforts at project management, the scope of data warehousing will always increase, correct? So, the scope of data warehouse will always increase. So, you may not have a boundary, right? Okay, we have only till this, we have to, look after the work. It's not like that. It will ever, increasing. So, maybe some different files need to be added. Okay, different business geographical regions is added, and that data has to be integrated into the data warehouse. So this will always keep on increasing. Fine. uh, yeah. So applications of database, fine, in the banking, airlines, so almost all the sectors, you have the applications of database and data warehousing, right? So as I was mentioning that the database application is for the is application oriented. Application oriented, like, yeah, here you have this for the banking. Suppose for the banking you have account related activities, right, or customer information system. You have payments, you have deposits, loans, credit cards, etc. So for all of these, right, you have different applications. Fine. So in that case, for all of these applications, right, you are using the database. Fine. For the payment system, for the deposits and all these things, so different systems. But in case of data warehouse, what it will be that you are going to analyze the maybe the bank loan fraud, or maybe the eligible customers, maybe something like that, right? So you are going to check all of their information. Okay, you are going to check their payments, deposits, or loans. All of these things you are going to bring it into one place, and you are checking their information. Okay, analyzing their information, and based on that you are taking some decision, right? So here you can see the banking, right? It may be to manage the resources available on the desk effectively. It used the banking sector to manage you. It is used in the banking sector to manage the resources available on the desk effectively. So whatever resources are there, right, you are going to use it effectively. Here it is application oriented. Fine. And there it is. For overall, you are going to subject oriented, like, okay, you want to do customer analysis, you want to do something different, right? So all of those you can just have it there. In airlines, you have the reservations and schedule information, right? Reservation systems, booking systems, right? So for bookings, you are just having an application, and in every passenger goes for a ticket, you sell it, and that is stored in the database, right? And you want to analyze the airline system, right? You want to analyze the airlines, manage the operations, like crew assignment, analyzing of routes, right? Frequent flyer program discount schemes for passengers. So like that, you want to, you have to use the data warehousing. So analyzing routes, and what does that mean? So you are analyzing routes, different routes, based on the cost, like how much fuel it will cost you, right, when you are taking this route, that route, and how much time it is taking to reach to other place, right? So all of these things, and how many passengers are also onboarding on that route. So there are so many things involved. right? The passenger information, the cost information, the fuel information. So many things involved in analyzing the route. So everything has to be brought into at one place, right? For this purpose, and that's what you are going to use the data warehousing for, right? Yeah. So similarly, you have in the healthcare systems, right? In the healthcare systems, insurance sector, retail chain, right? In universities, telecommunications. So all of these things, you have this database usage, and for different purpose. So maybe in universities, the student information logging, course registration, right? Colleges and results. So all these things use databases, whereas the university may be, trying to analyze the student information, right? In that case, okay, so trying to utilize the analyze the student information. So that in that case, that need to be, data warehouse need to be used in those cases. But only for registration, you don't need to use the data warehousing. This is only will keep the record, right? This will only enter the record into the system. It is not doing anything else. Okay, that's why we just need to use the database, right? Yeah. So these are the various things we have as part of the database and data warehouse. You For more understanding, please check the uh, various sources, various websites. Okay, one by one, and this is not, as I said, this is what not one day process. It will take some time if you are not understanding few of the concept, right? You have to just keep on learning bit by bit. You don't need to learn everything just in one day. Okay. Fine. So now we are going to see the data modeling concept. So we are having right in database, as I was telling that in database we are doing what the architect will be doing. They will be creating the ER modeling, right? ER modeling, like what are the different tables should be there, how those should be connected, right? Entity relationship modeling will be there. Entity relationship, every entity has to be connected to each other, right? So those will be created using the, and how it will be like entity relationship modeling. Let me just go to the system. So it will be like this entity relationship modeling. This is a DB like this. Okay, they will create the ER modeling, and this will be like this. So before, here you can see this is the OLTP system, right? This is OLTP system, and each and every tables are here created it's in the normalized form, and you can see different schemas, sales, purchasing, persons. So these are the different subject areas, for the data warehouse. Okay, sales, purchases, person, production, human resources. So these are subject areas, right? But these subject areas, you can see these subject areas are again subdivided, and all of the different OLTP tables are available here. Okay, like that. So these will be created before the database is created. Before the database is created, first this ER modeling will be done. Fine. This ER modeling will be done, and based on that, each and every tables will be created. How we are going to get the information from different systems, right? From different sources. So all of those things first, it has to be worked out, and then the building of data warehousing will be started. Okay. So similarly, in case of data warehouse, in case of our reporting, we are going to use the data modeling. Okay, data modeling concepts uh, like the ER modeling, entity relationship modeling. So data modeling concept here. What are the different data modeling concept we have in case of data warehouse? So we have these three schemas we will be creating. Okay, like this we are creating. We will be creating the data model. Okay, star schema, snowflake schema, or constellation schema. Okay, these are
Sorry, can I
again.
can I
Yeah,
ask a question? I'm sorry.
yeah, please.
For the ER modeling, who creates that? Is it the reporting team or is there a special team that create the ER model?
Yeah, those are the database modeler. Those not even the resources who are taking care of the databases, not even those people. Those are different architect or some other people. Okay, experienced folks, whoever is. So that is again that is the very first things that ER modeling and everything is created. The very first thing the data. The system is in place, right? And for that, very experienced people will be involved. So not the reporting guys or analyst will be creating that. Even analyst will be only creating this data model here in the, in case of data warehouse, in the reporting tools, not the ER modeling. So ER modeling will be created by the modeler, okay, database architect and all, right?
Okay, thank you.
Yeah. And here, as far as we are concerned, right, as a database, as a reporting analyst, right, as an analyst, what do we have? Data analyst. We are concerned with these, data models. Okay, we are going to create. We are only concerned with the reporting data models, not the even the data warehouse models. Fine. So here in this case, we need to understand these few modeling concepts, and the same concept will be also used in the data warehouse. The same concept are being used also in the data warehouse. The star schema, snowflake schema, and constellation schema. These are the three, very, these are the three modeling concepts we are going to use in our model, reporting model. Okay. In our these either in the data warehouse or in the reporting systems. Right. So what are the schema star schema? What is star schema? In star schema, we have only one fact table. In star schema, we have one fact table and one dimension table connected to each. Okay. So you may ask, like, what is the fact table? Right. So fact table will have only the measures, okay, and not any attributes, not the descriptive information. Okay, fact table will have only the measures and the key values, key columns. So what are those key columns? Those key columns are, these here we have the foreign key information, okay, which is related to the dimensions. Dimensions will have primary key for each of the dimension, and for the same dimension, we have the foreign key, which will be available in the fact table. So fact table will have only the keys information and the business values or the fact, okay, business values or facts, or like in case of order tables we have the order information, how many quantities ordered, how much how much money is, for how what is the revenue. So maybe this kind of information, only the fact information measures will be available in the fact table, okay, and not anything else. And key and fact, and we have only one dimension connected to the fact. That means this fact table will be normalized, also these dimensions will be also normalized in the sense everything will be in one table. All the related information for this dimension will be in one table only. It will not be further divided into another table, right? So we are just going to see what does that mean, if whether if I'm when I am saying it is totally normalized, not this is normalized and not, divided into another table, split it into another table. What does that mean? That we have, suppose we have here location dimension. Okay, we have location dimension, location table, and this location is also, we can further divide it into city information. You can see this location is divided, splitted into two tables. So we can also have the same location into one table, right? And we can say this is location dimension. So this street, and we have the city key, and then we have the city information, state information, and country information. So what we are doing, we are just keeping all of these things into one table. Okay, into one table. So in that case, what will happen? This will be denormalized, and that's what we have in case of, so that's what we have in case of the star schema, that we don't subdivide any dimension into another, or split any dimension into another dimension. We just have everything normalized here. So one fact table and one dimension. Okay. Uh, so here, like sales, suppose we have a sales information. So in the sales information, you can see we have only foreign keys. Okay, foreign keys, and we have the sales quantity, sales price, amount, receipt ID, or time stamp. So you can see the date information, whichever is related to the transactions, that is available. The the facts or measures will be available, and the keys will be available, and no other descriptive columns are available in the fact table. Fine. And in the dimension table, so it will have, it will be normalized. And in case of suppose the date dimension, we have only date related information. In case of product and dimension, we have only product related information. Okay, we have only product related information. So customer dimension, we have all the customer related information, and this is not subdivided or split into another dimension. Okay, so only one dimension connected to the fact table, and that is the star schema. And here also in our case, when we are building our model, right, we started with the model, right, and this is, here you can see that this is the dimension, this is the fact table. And in this fact table, you can see, and this fact table is the orders information. And you can see here, we have the sales, stock, store ID. This is again key, right? Foreign key, then revenue, and we have some fact information, right? Measures, prices, dates, and only keys. So apart from that, we don't have anything else. And this is what the measures, this is what the fact table is in our case. Fine. This is the fact table, and store city is the dimension table, right? And this city, you can see all the information related to this store cities, right, are all available in the one table. Fine. So this is dimension and this is table. Similarly, we have many other tables, what we are, whichever we are going to, use in some time. Okay. Here you can see this is star schema format, and all of the tables are denormalized. So what is the benefit of this denormalization? You just need to, create one relationship. You don't have to create, a complex relationship, like you are creating this fact table to this dimension table to another dimension table. You don't need to do that. You just need to connect only, you just need to have one connection. And this is faster even. Why this is faster? Network usage will be less, right? Also data is already normalized at one place, so directly from one database you are just getting the data, right? So many less complexity is there for getting the data, integrating the data, right? Fetching the data. So there are so many there are so many uh, fine advantages are there for this star schema, and you can find the detail in the internet on these, right? The various advantages of this. Fine. Also, I have this, I can share this document with you people so that you can also go through this. Fine. For this star schema, and we are going to use whenever if we find it, if our data is like that, that we should use the star schema. So this has to start from the data warehousing itself. Okay, the data warehousing tables should be such that we can create the star schema modeling in our reporting. So this has to start from the data warehousing. When you are working on a project, right, you have to give your input. Okay, we need data like this, so they can also rethink on their design, data warehouse design. Fine. So you have to also give your input if you are involved at that phase of time, at that phase, during that phase. Okay, during the data warehousing modeling phase, right? You have to provide your input that we need data like this. Okay, so that we can easily bring the data for the reporting. Right. So so many times you are involved, many times the analysts are uh, involved later, right? But during design, the experts will be there. So no worries. So mostly data warehousing, during data warehousing modeling, during time, the experts will be there who will be deciding on mostly on this star schema or snowflake schema, whether they should have the bring the data, and that will be decided based on the nature of the data, whatever how what means what data they are getting, how they are getting the data from different places, and how the data is available now present in the database, and how easily they can bring the data. So all of these things, right, they will consider all of these, and based on that they will decide on creating the model. Fine, whether they should use the star schema or they should create the snowflake schema. As far as this star schema goes, it is having just one dimension connected to the fact table. Fine. And when we come to the second, modeling concept is snowflake schema. We have the star schema, and apart from that, we have more dimensions connected to the dimensions. So we may have more than one connections to the fact table, the joins. Right here, it is little it is not totally denormalized, yet partially denormalized. The tables are partially denormalized, and here you will have more connections, right? One connection to the fact, then again dimension connected to the dimension. So like that, it will be created, right? In the during the snowflake schema creation, right? So it is not just one connection, but you have more connections to the dimensions. Fine. And the disadvantage is it is not in denormalized form, so data is not in one table. You have to get the data again. You have to create a relationship and get the data. So their network overhead and all those things will be there. So data will be little slow. Performance will be little slow. Performance will be slower in case of snowflake schema than the star schema, because star schema less network overhead. Fine. This fact table is there, then dimension, time dimension, then you have the branch information. So like that, and here you can see that this is fact table is connected to the item dimension, and item dimension is again connected to the supply dimension, right? So we in case of star schema format, what we would have done, that the same supply information we would have also given into the same table like item table. Okay. So it's like, okay, now here normalized, in the normalized form we have. So you can also check 1NF, 2NF, 3NF form, okay, of these tables, like how those tables are created, like second normal forms, first normal form, second normal form, third normal form, and why those are created, right? You can check also those concepts. Fine. So this is Snowflake schema we have. Do you have any question on the Snowflake schema or the star schema?
So do you have any particular, website or anywhere that we get to see detailed information about these concepts?
Yeah, we have lot of actually we have lot of websites. I can share with you. I need to check. Almost see this data warehousing concept. You will find these details everywhere. Okay.
Yeah, if
Uh,
you have any personal favorite.
yeah, I'll check. I don't remember. Okay.
Mhm.
But I will check. Yeah,
Okay. Yeah, thank you.
fine. Then we have this star schema, snowflake schema, and next one is the third one is the constellation schema. So this is nothing but again the snowflake schema, star schema or snowflake schema connected through a common dimension. Right here you can see two fact table, but in earlier cases you have only one fact table. Okay, you have only one fact table. So there will be only one fact table in case of star schema and connected to many dimensions, right? In similarly, in case of snowflake schema, you have only one fact table connected to the dimensions. But while we are going for the constellation schema, that means you have two different, fact table. You have two different measures information. Okay, maybe you have sales, maybe you have also budget. Okay, maybe you have something else connected, which are both of those are connected to each other, right? And you want to analyze at one place. So in that case you have to use the okay, you have to use the common dimension to connect both of these fact tables and analyze the data at one place, right? So actuals and budgets, maybe like that, right? Or forecasting. So you have different fact tables, okay, and you are connecting through a common dimension, right? And in that case, you have to use the constellation schema. So here you have a common dimension, and which will connect bridge, which will act as a bridge between two fact table, right? And that this is called a constellation schema. Here you can see in this case, you have the sales fact table, sales information, right? You have the shipping information, right? And this shipping and sales are connected through common dimensions. That location, you have item, right? So these are the common dimensions, and you have the item, you have the time. So these are the common dimensions through which these two tables, two fact tables, sales fact table and shipping fact table are connected, right? So this is called constellation schema, fact constellation, right? So that's what we have in case in data modeling concept. So these are the three data modeling concept, and uh, whenever whenever it is possible, you go for the star schema because it has a lot of advantages whenever it is possible. Mostly we should go for the star schema. Okay, and yeah, then we have based on the data, based on the nature of the data or nature of the modeling, nature of the data we have in the database, data warehouse. We have to also decide on this. Fine. Now we have also these few concepts, key concepts, right? What are the different keys? So you don't need to, as a data analyst, right, we don't need to understand all of these key concepts. But if you are, if you want to have more knowledge on the data housing, you should also understand this candidate key, these different composite key, compound key, and already you know this unique key, what is unique key, what is foreign key, and primary key, right? So these are few things here. Primary key we know the unique key, we know the foreign key, and here we have candidate key, super key, alternate key, and composite key. These are some keys which are being considered during the data house design and all these things, right? And why those are considered, like they want to check which of these key can be create a used as a key for uniquely identifying a data, right? Uniquely identifying a tuple in the database. So that has to be so on for during that time database data warehouse design and to use in the data warehouse, you just need to understand these few keys, super keys, alternate keys, composite keys, and candidate keys. So what is the candidate key? You can say like the minimal key or minimal key. Suppose you have a super key, right? Super key and candidate key are connected. So super key, what is super key? You have so many combinations of columns in a table, right? Combinations of column in a table, which can be used as a primary key, or which can uniquely identify a column, which can uniquely identify a tuple, a row, right? So apart within that super key, you have whichever is the minimal key, okay, less number of columns, that will be used as candidate key, right? So yeah, you just go through these concepts, different composite key, using two or more number of columns to uniquely identify a table. Uh, we can say this composite key or compound key. So unique keys, it will uniquely identify a column, right? Foreign keys, based on the primary key, we have the key on the other table, right? In the fact table, we have this foreign key corresponding to the primary key for a dimension. So this all of these things. So these are referential key. It will reference the primary or dimension table. Okay, primary key. So these few concepts you just go through in the websites. I will share the website information, right? And yeah, please go through these things. And but you don't need all of these to work on the uh, reporting tools. Fine, but you should have understanding on the different concepts so that you feel more comfortable with the data warehousing concepts. Right? Yeah. So that's what we have for today's session. We'll start, working on the modeling data. Yeah, we are going to use these as we mentioned before, that we are going to use this adventure works, all the data sets. Here we have these tables, and I will share all of these tables with you also. Whichever table are being used in the classes, I will keep on sharing this, data, right? So that you can use that. Right. So we'll be using these data sets for creating the models and all these things. And we have already started creating the model, right? And yeah, next session, that means tomorrow, we'll create the model and we'll move ahead for the visualizations. We'll learn these different visualizations, charts and all, right? Yeah, that's all we have for today's session. We'll meet tomorrow. You have any question before we end up this session?
No question.
Okay. Yeah. Okay, then we'll meet tomorrow. And thank you.
Thank you.
Thank you.
Thank you.
Bye.